I got to get myself set up here and switch screen. Excuse me. Not you. Not you either. No, that's not it. Okay. Okay. Give me a moment to get set up here. It's a couple minutes late. A lot going on. Still not really fully set up, but let's see here. First, we got to do pretty much a sound check to make sure there's no humming or anything, because I'm using a different microphone system, and if that is an issue, then we're gonna have to go back to the old system. So let's see. All right, 8 minutes late. Oh man, let me see. I got you. If you are in the room, and I'd like you to tell me what test you're preparing for, what location you're from or in, and we'll take it from there. But I'd like to see who's in the room. Hey, Kara, good to see you again today. And in the meantime, what I'll be doing is checking my... Now, volume. Is the volume okay? That's the first thing we have to establish. Is the volume okay? Can you guys hear me clearly? There's no reverberation. Very good. All right. It's not high. I'm Kino. That was like driving me nuts. Like, okay. Good. Okay, volume is perfect. Outstanding. Okay, folks. Oh, before I forget, still working on the desk, guys. But all right, this is a shout out to one of my subscribers. His name is Thomas Cruiser. He took the aviation selection test battery, and he received a 62. You gotta hit 50 just to be competitive, just to be like in the room. But he got a 62, which is an outstanding score, and he got 777s. And I'm just proud to say that he's a subscriber of mine. He's been watching my videos. He's been following me. And I thought that was like pretty cool. I talked with him today for a debrief. So like, if you guys want jets, man, like, you know, just let me get this out of my ear, because I'm probably going to yell a little bit louder than I should, or raise my voice a little bit louder than I should. Like when I wear earplugs when I'm at work, I talk louder. So yeah, guys, dude, this is no joke, man. This is what we do. We're very proud of Thomas, and that's a hell of a score. I'm not sure he's up in the top 10 though, because Jay was like he got like a 61 or a 63. I can't remember. But he's definitely got a flight contract. And, you know, that's what we do here. We prepare you guys for the test so you guys can go to flight school and, you know, go zoom all over the world. So, again, I guess I'm so happy to just be up and running. I'm Kino Thomas from STEMwithKino.com. For all you guys that might be just new to the room or whatever, new to my site, or my channel, I should say. So yeah, very, very excited. And also the new I got a new area, new office area. I'm spending less money and I got more room. And a friend of mine was like, "What's the drawback?" I mean, so far there really hasn't been any drawbacks, and I'm adjusting pretty well. We're looking for questions, guys. Looking for questions. If you have a question, and for people new in the room or people that have been coming here, you get your test prep book. Do I have a test prep book? Yeah, I do. You know, take your smartphone. Just take your smartphone, take a picture, and send it to KinoThomas@gmail.com. I'll go ahead and I'll type that in. forgot the dot, guys. All right, Keno Thomas, gmail.com. Okay, so that is the email, and what you can do is you can just send that in, and you know, you can send questions and I can address them, or you can type them in. It's up to you. Okay, so still not seeing anything yet. Trying to think. What I'm going to start doing is I'm going to start coming up with a really, really tough question that I came across throughout the week during my tutoring journey. And I'm kind of thinking of something now because you guys don't always throw questions up in the meantime. I have one. This is for the aviation guys. And I'm not beating the client up that, when I asked them, I was like, well, what's ground effect? And a lot of guys, they refer to it as, oh, it's like a pillow cushion in the air. I kind of, I don't like that particular definition. The definition that I like for ground effect is, okay, first we'll define ground effect, and then we'll talk about some of the symptoms that occur during a ground effect situation. Okay, so ground effect is the Earth's interference with the airfoil patterns about the wing. All right, so what I'm going to do here is I'm going to draw an airfoil, and an airfoil is any device used to produce lift. Now, this is our wing. We have our chord, leading edge, trailing edge, upper camber, lower camber. And as this wing flies, if we can find a different color, it's kind of like synonymous with you sticking your hand out the window like when you were a little kid. All right. Now, you feel wind, but your hand is actually passing through the air molecules. And there's actually, I'll be remiss if I don't talk about I'm sorry, guys. Now you got your laminar airflow there, but there's a natural, the air molecules will actually jump up or rise up as this wing, because there's negative pressure at the top, positive pressure at the bottom, and then boom. All right. So, and then the air molecules will kind of like fall back to their original spot, so to speak, right? So there's a normal upwash and downwash that is occurring as the wing flies through the air. So we have a natural upwash and downwash. Now this is cool, like if we're more than one wingspan above the Earth's surface. But typically what occurs when we get near runways, don't laugh at my artwork, guys. And the lighting is off. I noticed that on the cam, and I will address that, but I'll take care of that. We'll just deal with the lighting this week. But when the aircraft comes in, when it takes off or it's about to land, it's less than one wingspan. And what happens is when that airfoil is this low, I'll just draw a little airflow, it doesn't have that same oomph as far as upwash and downwash. It's actually a reduced upwash and downwash that occurs. And it's because all under here at altitude, all we have, or above more than one wingspan, all we have is air molecules. And they can come up and drop off, upwash, downwash, as the aircraft flies through the air. Here, it is a diminished upwash, downwash. Now, what occurs? Well, let's come back to the four forces of flight. We have lift, we have thrust, we have weight, and we have drag. Okay. So what happens is we get reduced drag, but you get the same amount of lift. All right. So that's why you may feel when you're trying to land, you may just kind of, man, it doesn't feel like it wants to land because you have the same lift and diminish or less drag. going on. So we have the same amount of lift, less drag, and that's why you feel like there's a, excuse me, cushion of air. All right. So that is ground effect. All right. Ground effect is the Earth's surface interfering with the airflow patterns about an airfoil or a wing. Okay. That's specifically what ground effect is. Now, let's go into things that could happen. Okay. Now, on hot, humid days, normally, this is when this is pretty pronounced. All right. Now, on a hot and humid day, let's say we take off at 65 knots, and the KIS means indicated airspeed, what the pilot is seeing on the instrument panel. Now, normally, the aircraft becomes airborne at 65 knots. Well, on this particular hot, humid day, pilot looks at the dial, and at 50 knots indicated, the plane just goes, whoosh, just lifts off. Like, wow, this is amazing, right? Now, you're okay, but you have to stay within the ground effect until you get to the recommended speed. So you let it break around, you level out, and you just stay within one wingspan. If you do not, and you continue climbing, then this drag is going to come back. You probably won't have the lift or the airspeed, and you may settle back down to the ground abruptly and then possibly damage like your landing gear or something like that. But in short field takeoffs, that's kind of what we do with short field or soft field takeoffs. You know, the control yoke is way, way back, and you jam the throttle, and the plane's just, and with the yoke all the way back, you got the elevator trying to get that nose off the ground, and that plane up in the air. But you have to settle until you reach your recommended takeoff speed. So ground effect is really, really important, because if you don't stay within here and you try to go there, you're going to abruptly go back down. So we build our speed till we have our speed, and then we could just do a normal climb, business as usual. On landing, when you come in, you may have to, depending on how gusty and windy it is, I would kind of just make sure, you know, I have enough runway where I can plan for the plane not wanting to settle to the runway. So it'll just kind of like, you'll round out, you'll flare, and you'll just be sitting there, and the plane will just be like, you know, and you'll just be like, come on, man, land, you know, and that cushion of air, that extra lift will be there. That drag will be diminished, so it will take a while to settle down. So you want to plan your approach accordingly. All right, so I know that was a little heavy, but this is what's going to happen when you guys don't give me questions. All right, so let's see. Let's see what we got. Okay. And then, right, you guys send me questions, and then I'm going to be picky, right? I don't like that one. I don't like that one. I'm sorry. That's why I send bunches and bunches of questions, because I don't want to do something. I don't want to beat a dead horse. I want to, you know, try to do some things that we haven't really discovered. And no, it's not wrong. All right. I'm looking. I need like a co-host to like just talk. I know what I will do is I think, and I'll give credit to credit is due. Kara brought in she emailed me a really, really cool handout. And let's see. I was looking for that handout you sent me. It was a really, really good handout. And I think over the next couple weeks, I will address this handout if I can find it. I had it. I know I had it. Let's see. I'll find it. It'll just take a second, guys. I know a couple things that was on it. You should know certain things. Like you should know that there's 4 quarts in a gallon, 16 ounces in a pound. Your conversions, 1 inch equals 2.54 centimeters. I don't think that was on it, but it's just something I'm making. Yeah, could you please? Yeah. This Keno, he be tripping, man. OAR, New Jersey. New Jersey, and you hate the cold weather. We talked about that. We were talking about the cold weather. How many yards in a mile? That's a great question. How many yards in a mile? Well, how many yards in a mile? That's a great one. All right. 1 yard is equivalent to 3 feet. And so X amount of yards, no, can't do that yet. I'm jumping the gun, y'all. All right, 1 yard is 3 feet. 5,280 feet and 1 mile. And how many yards in a mile? Does that take care of us? So how many yards and 1 mile? Okay, I'm getting my conversions mentally like mixed up for some reason. So I know that there's 3 feet in a yard. So if I divide by 3, 5,280 feet, 1, 3, 2, 2 comes down, 7, 2, 1. Oh wow, and it might even come out to a really nice whole number. 1,760 yards are in that 5,280 feet. So that's pretty cool. 1,760 is the answer to your question. All right. Okay, so I hope everybody got that. If not, it's DVRable. You can go back. Okay, so I like this guide because it just kind of gives you an idea of maybe some of the differences or conversions that you're going to have to know. There's 16 ounces in a pound. There's 8 pints in a gallon. There's 4 quarts in a gallon. There's 2,000 pounds in 1 ton. Moving right along. I wonder if I can just, yeah, baby. All right, as far as you should know the difference between complementary and supplementary angles, which means, complementary angle, pints in a quart. How many pints in a quart? Ooh, boy. I'm going to get you there. Pints in a quart, man. What's up now? I'm going to get back to that, though. So supplemental angles are two angles that add up to 180 degrees. Complementary are, so I would think of it like this. C becomes before S in the alphabet. So the C complementary angles are add up to 90 degrees, and the supplementary angles add up to 180 degrees. We'll talk about equations and word problems and a little bit. Okay, so let's talk about the working together problem. All right, in a working together problem, these are very, very, very easy. Let's say, for instance, I'll just make one up. One person can complete an assignment in 20 minutes, and another person can complete the assignment in 30 minutes. All right, so one does it in 20, one does it in 30. All right, so it's set up like this. All right, one guy does it in 20 minutes, plus the guy that does it in 30 minutes. Almost too many zeros. And I'm jumping the gun. I'm like getting used to this, and no more sitting down. I'm gonna stand up while I do my presentations from now on. And let's see here. So we have one person. This represents the person that does the work in 20 minutes. This person represents the work that does it in 30 minutes. And it's equal to one job, one particular job. So collectively, we want to know how long is it going to take them. If this person can do it in 20 and this guy can do it in 30. This is how you set it up. X over 20 plus X over 30 equals 1. Now, in this case, it's not like we do our regular fractions. You're going to have to come up with a common denominator. The common denominator between these two numbers is going to be 60. All right, so that means that each term is going to be multiplied by 60. So, and you have to think of it as 60 over 1 because it is a whole number. And in fraction form, it is a 60. So 60 over 20 is going to be 30x. And this is going to be 20x. Now, hold on. See what happens when you move too fast? 3x, 2x. All right, but I always catch myself. All right, so let's do it. 60 over 1 times x over 20 becomes 60x over 20. All right, and that becomes 3. And then 60 over 1 times x over 30 becomes 60x over 30, which is 2x, which is actually is 2. All right. Or, yeah, I got to put the x's there because 20 times 3x is 60x and 30 times 2x. But really, the only thing that really happened is these kind of boop, flip places. All right. So, all right, 2x, 3x. And then this is multiplied by 60 as well. So 3x plus 2x equals 60. 5x is equal to 60. And x is equal to 12. So that's about right. So it will take both of these people 12 minutes to complete the job, the said job. All right. So to recap, the question states, or I came up with, one worker can do a job in 20 minutes. It could be typing, it could be jogging, whatever. Not jogging, but typing, some type of job to complete, stuffing envelopes. So this person can stuff envelopes in 20 minutes. This person can stuff and sew envelopes in 30 minutes. What we did was we set x over the number of minutes plus x over the number of minutes of both people. They have to be added and equate to one job. We find a common denominator. After finding that common denominator, the common denominator must be multiply by each term, the x over 20, x over 30, and the 1. And then that brings us to, and we did the math over here, and we got 3x plus 2x equals 60. We combine like terms, 5x equals 60. X is equal to 12 minutes. So that's our answer. So with a lot of these problems, it's all about the setup, and I promise about the lighting because it looks bad on this side. I think I'm going to use a darker marker as well, but I will definitely have the lighting squared away next week. But was that clear to everybody, though? That's my most important thing. I want to make sure it's clear. At least 3 people in the room. Just type clear on the message board, and we will move on. All right, Caroline's in the building. We'll see you tomorrow morning. Okay. 2 clears is good enough for me. All right, so. And if there's something like you probably don't understand, like, just go, read a little, like I told a guy, like, look, watch 2 minutes of the video, write down everything, and just look at it for understanding, and then boom. Now, I'll do this one as well, but we have an example. How much pure acid must be added to 12 ounces of a 40% acid solution in order to produce a 60% acid solution? This is relatively easy, but I always teach this like containers. I'd like you guys to get a mental picture of what's being done. So we have a container here, plus we have a container here, and it is going to equal a resultant container. So we have our containers. We have our 3 containers. So we have 12 ounces, 1, 2, OZ of a 40% solution. And then we're going to add a 100% solution, which is 1.0. The question is asking how much, so that is unknown. But at the end of the day, we want a 0.6 or 60% solution. So we want a 60% solution here, we have 100% here, and we have 40% here. Now what we have out here is the percent, but this is the decimal equivalent of what we have going on here. All right, so 12 ounces, we're going to add a certain amount of ounces. So what we do is we multiply downward. Here, we're going to multiply downward here, and we're going to multiply times, and I'll put an X there for multiplication, the sum of these 2 containers, the 12 ounces and the X. So how's that going to look when we set up our equation, and it's all about the setup? 12 times 0.4 plus X times 1 equals 0.6 times the sum of 12 plus X. All right. And once you set that up, it's all about the setup. Then you're good. We should have 4.8 here. We should have 1X. We should have 7.2. And we should have 6X there. All right. Now what we need to do is we need to determine which side is X greater on. And X is greater on this side because it's 1. Hold on. This was a 0.6. Sorry, guys. When we distribute it in here, 7.2 and then 0.6x. So it's still greater on this side. So when we bring 0.6 over here, it becomes 0.4 because this becomes a negative. 0.4x. And when 4.8 goes to that side, it becomes negative. 7.2 minus 4.8. 2, right, 2.4. Jesus, what is wrong with me? 2.4 there, 2.4 there. So I see 6 ounces. See what the answer is? Yeah, 6. So in order to raise the 12 ounce 40% solution to a 60% solution. We're going to use pure acid when we have to add 6 ounces. And at the end, we're going to have 18 ounces, but it'll be a 60% solution. Type clear if you guys understood what I just did. If you need to go back, this is DVRable, so it's not a problem. But I just want to see a couple clears in the room, and then we'll move forward. Very good. Very good. All right. Now, this is a pretty well, we'll just we'll work with it. All right. If you just listen to it and you understand how we did our work together, problem that we did earlier, then this all makes sense. Okay. So let's just say one person can complete a project in 20 days. All right. And B can do the same thing. And actually, it's probably going to wind up the same. Oh, no, I guess not. Okay. All right. So we'll walk through it anyway. All right. Person A can complete a project in 20 days. Person B can complete a project in 30 days. If A and B start working, yeah, that's why it changes. If A and B start working on a project together, and A quits 10 days before the project is completed, and how many days will the project be completed? This sucks. Again, I will read it out again. A can complete a project in 20 days and B can complete the same project in 30 days. If A and B start working on a project together and A quits 10 days before the project is completed, and how many days will the project be completed? Now, in all honesty, I have not solved this. I haven't even looked at this problem before. There is an explanation, and I would just like to do a walkthrough just to make sure that we understand it. All right. So the explanatory answer, if A can do a project in 20 days, A will complete it in 1/20th of the project daily. All right. That makes sense so far. Hopefully it does to you guys. So what they're saying is, if A takes 20 days to complete a project, that means 1/20th of those 20 days, they're doing 1/20th of the project every day that goes by. And I'll put PROJ for the project. So out of 20 days, they're completing 1/20th of the project. B, they say that B does it in 30 days. So every day, he or she is completing 1/30th of the project. All right. Now, let the total number of days taken to complete the project be X days. All right. Then B would have worked for all X days, while A would have worked for X minus 10 days. So however many days, I'll put the number sign of days. So however many of days that it takes to complete this project, B goes the whole full length, A takes 10. So in category A and B, number of days, B does the whole time, A does 10 minus X. Type in clear if we're good up to that point. I'd like to see at least 3 clears. And I'll wait. I know there's a lag. Okay, so we're good up to that point. I see at least 3 clears. I'm going to proceed. So this is the number of days A does it. This is the number of the days B. B hangs in there. A takes away 10 days. All right. So here's what it's gonna look like. All right, we gotta put the number of days over the full amount. So it's kind of like a percentage kind of. We said that A can do this in 20 days and B can do it in 30 days. All right. So it's very, very similar to our work together, but just kind of like work together minus day. So the plus symbol is there, and this is going to equal one job still. But we're talking number of days, not minutes like that other question. And then this person takes 10 days off. All right. So it's the number of days unknown over days that it will complete them to complete the job. Please type in clear if we're good to that point. I know there's a lag, so I'll wait. Okay, clear, clear, clear. Okay, so now at this point, what I would do is I would attempt to solve it like I would solve anything else. 60 is the common denominator, lowest common denominator. Now, here's the problem. A lot of you guys don't deal with this type of math. So 60 over 1 times x minus 10. I would put a parenthesis over here because it's going to be distributed. All right. So looking at 60x minus 60 over 20. All right. And no. Oh, yeah. All right. So would that be 3x minus 3? All right, 3x minus 3 plus, and then we multiply this by 60. It's going to wind up being 2x, and then that's going to equal 60 multiplied by that. Now, I'm assuming we'll just combine like terms and everything will work out nice and neat. We shall see. I'm always doing this, right? So 5x equals, if 3 goes across, 63 and 5. 63. I don't think this is it. 1, 5, 1, 3, 2, 12, 1, 0, 2, 12.2. I don't think that's it. Their answer is 18. And like I said, this is my first time looking at it. They got 18. So let's step back and look. It did multiply 60 by each term. And I got 60x minus 60 over 20, which would work out to 3x minus 3. And that came down. This came down to 2x, 5, 63. They got 18 for some reason. So I'm going to have to do some research on that and figure out what, but just so you know, the answer according to this answer sheet, it is 18. All right. So that is something I'm definitely going to do some research on and revisit. But that is a tough question. I mean, you know, moving right along. All right. Amount of discount. That's easy. We've done that so many times before. Seen that before. We've seen you before. I love this one. This is I've done it before. It is a very tough one. But it is awesome at making sure that you stay structured and you stay structured, and it just makes sure that you follow your problem solving tactics you know, you just gotta, what's the word I'm looking for? I'm not sure the word I'm looking for. But at any rate, any word problem, we line by line is how we read a line, we diagram. We read a line, we diagram. That's how you get the big picture. Don't read through the whole thing and then try to piece it together, because you're probably going to run into problems. Okay, so a bridge crosses a river that is 1,520 feet wide. So a bridge crosses a river, and we have river banks, I'm assuming. And here's the water. 1,520 feet wide. All right, so again, sometimes I read it a couple times. A bridge crosses a river that is 520 feet wide. One bank of the river holds 1/5 of the bridge. Let's say this. This is where the bridge stops. So we'll say that this is 1/5 of the bridge. From here to here is 1/5. And the other holds 1/6. So let's make a little line here and our little line here. And we'll say that this is 1/6 of the bridge. This is 1/5. And what they're asking is, how long is the bridge? How long is the bridge? All right. So this is pretty cool, because what we have here is we have an unknown distance, do we not? And we have an unknown distance here. But these two unknown distances, plus 520, because that is the length of the river, or the width of the river, is going to equal to some unknown number. So the initial equation is going to look like this. It's going to look like 1/6x, and then we're going to add the fifth x, and then we're going to add 1,520, and that is going to equal the whole structure. So this is 1/6 of the structure, this is 1/5 of the structure, and then this is 520. And if we solve for x, then what's going to happen is we're going to actually come up with the total length of the bridge, if I don't drop stuff. All right, so what do you think we could do first, guys? Probably combine the 1/5 and the 1/6. All right. And then 30th is probably the lowest common denominator. All right, so if I multiply each term by 30, all right, and you see an ongoing theme here. If I multiply this by 30 over 1, this is going to be 5x. 30 over 1. And this is going to be 6x. And then 1520 times 30. Actually, you only need to do 152 times 3, 6, 15, 4, and then you add the 0 back. Actually, by 30, we add 2 zeros. Sorry. 45600 equals 30x. Are we good to that point? Please type in clear if we're good to that point. Okay, I got 3 clears. So we've multiplied each term by 30, all right? And so now we're going to combine like terms. And I'm just going to dig into our bridge a little bit there. All right. So 5 and 6x is 11x. Plus 45600 is equal to 30x. The 11 is going to go across, and 19, 19, and become 19x. And I would like someone to divide 45600 by 19, and give us an answer. Now the cool thing about this is we don't have this out in multiple choice, but we would probably do this, it will be done in multiple choice. Now, if the numbers in the answer selection were spaced far apart, I wouldn't even divide by 19, I use 20 and just nail the closest thing that I could find. But somebody give me an answer, guys. And please hit the like or dislike button. I'll get a little water. Well, Dennis, I know you got this one. Okay. Okay, anybody disagree? 2400? Anybody agree? Anybody agree, disagree? Give it a few more seconds. Maybe someone will respond. Okay. Dennis, you're absolutely right. The bridge is 2,400 feet long. So good job. So to recap, what they're telling you is that there's a bridge that goes across a river. The river is 1520 or 1,520 feet wide. One part of the bridge is supported. 1/5 of this bridge is supported by land, and 1/6 of this side is supported by land. So basically what we did was we have the complete span of the bridge and we have our unknown numbers. So all this is just basically added together. If you look at it, 1/6x plus 1/5 x plus 1520 equals x. All right. So it's pretty easy. Pretty easy. Once you add everything up and just solve for x. In order to get rid of the fractions, you find the lowest common denominator, multiply each term by the common denominator. Lowest common denominator, so we can work it out, because we don't want those fractions. We want nice, lovely whole numbers. Then that brings us to this. 45600 divided by 19. 2400. So that is the answer. Okay. So 9:56. Are there any final, like, just real quick questions? There's really nothing we're going to get done in the space of 4 minutes. So unless a problem comes up, I'll do my little spiel. Hi, I'm Keno. If you're just coming in watching this video, I'm Keno Thomas with STEM with Keno.com. What we do here is we prepare for all the military aptitude tests. I don't have my notes on the wall anymore. I haven't set them up. But the SIFT, I'm visualizing. The AFOQT, the ASVAB, the OAR, and the Aviation Selection Test Battery. That's what we prepare for. And all Federal Aviation Administration pilot testing. So that's from private pilot, instrument pilot, commercial pilot, airline transport pilot, flight instructor, initial instrument and multi-engine, aviation ground, basic, instrument, and advanced. I've taken every last one of those tests and passed them. Pretty much flying colors. Yeah, now that I think about it, yeah. I killed all his exams. So, you know, if this is what you're preparing for, I'm the guy you need to talk to. If you like, we're here every week, 9 to 10. Sometimes I am a little late, but I just moved offices, and so, but I got a lot more room, man. I can stretch, I can dance, I can do all kinds of stuff, so I'm loving it. Definitely more space is always good. What else? So yeah, if you're preparing for these tests, the live stream, I'm here every week. Okay, so if nothing else, you can kind of see some of these problems being worked out. You can present problems every week, and that's really all I have. So we will be going into the Hangout because I'm gonna switch over to the Hangout, and that is people. If you tutor with me and you want to come to the Hangout, send me an email. Otherwise, I will see you guys at our respective times that we have set up on the schedule. So that being said, please hit the like button. All right, just got my scores. Lord, okay, cool, awesome. All right, hold on, I need to switch that window. Just got my scores, P, N, V, Q, X 47, 74, 53. Okay, Lord of Flies. All right. So just kick me over that email, and I am going to prep for the Google Hangout, or I am going to prepare for dinner if nobody comes in. So I'll talk to you guys soon. I'm Keno Thomas with STEMwithKeno.com. I appreciate you guys watching, and I will see you next week, 9 p.m. Eastern next Friday. Bye-bye. Do my little finger thing, and bang. Okay.